Hi, and welcome to the Rice Northwest Museum of Rocks and Minerals. I'm your host, Garrett Romaine, and today I want to talk about meteorites. We recently put on display a small fragment of the famed Murchison meteorite, and I'm going to show you that in a second. But let me give you a little background on meteorites themselves. There are three different kinds. There are iron, stony, and stony. And even though there are only about 6% of the meteorites found, the iron meteorites are probably the most famous. This is an example of the Campo de Cielo meteorite found in Argentina. And you can see it got attacked by oxygen and water in the Earth's atmosphere immediately. And so it's rusting away. You can even see little pieces of it that spall off all the time down below. Here's another famed iron meteorite. This is from Canyon Diablo in Arizona at the Meteor Crater. And it is not quite as susceptible to rust as the Campo de Cielo. Here's an example of a layered tektite. This is from the border with Laos and Vietnam. And what's happened here is the impact of the meteorite fused all the material around it, all the alluvium and soil, and baked it into a volcanic glass, basically. It looks just like obsidian on a fresh surface. And you can see the layers in there, the redder, almost a volcanic clay. So we have other examples too from the impacts. We've got these impact breccia. This one's from Wisconsin at Glover's Bluff. We've got this great piece from Rochechouart, France, an impactite. And you can see all the different fragments in there are very angular. So it wasn't stream worn. This is from an explosion. Here's an example from the Ries crater in Germany. And again, it's a breccia. You can see the little pieces in there. That crater has been mapped. It's pretty well understood, and it's one of the more famous. But recently, scientists have pretty much settled on the Chicxulub crater in the Yucatan. It dates to 63 million years old, which is exactly the end of the age of dinosaurs, the difference between the Cretaceous and the Tertiary, so right on the KT boundary. And this one's about 100 miles across, so it's a giant. We also have examples of Oregon's famous meteorites. We've got the giant Morrow County stony meteorite, which was discovered in 1999 by a rockhound. And our most famous meteorite is the Willamette meteorite, found in 1902. You can see there's a couple of kids in there for kind of a proportion, see just how big it really is. And this one probably came to Oregon on an ice raft in the Missoula floods. There's no known associated impact crater with the Willamette meteorite. Right now it's on display at the American Museum of Natural History in New York City. We've got other examples. One thing that's really interesting is this Salem meteorite has a really thick fusion crust. The dark lines around the rock, the inside where it's fresh is nice light gray, but the outside is where it went through the atmosphere and got hot. Another cool example is from Klamath Falls, a 38-pounder, and it's got an example of what are called Widmanstätten patterns. If you polish these iron meteorites and then etch them with an acid, you find this unique pattern where the crystals have cooled slowly, and these are characteristic of iron meteorites. So Widmanstätten patterns are pretty cool. But let's talk about the Murchison meteorite. It was an observed fall, meaning it was seen as it smoked across the sky in 1969. It broke into three pieces. There was an audible tremor as it hit the Earth, and then in the next few weeks, it was pretty easy to track down, and people collected about 220 pounds of material. Now, it's a stony meteorite, and there's two different kinds of stony meteorites. Some have chondrules and some don't, so they're either chondrites or achondrites. Now, you can see the little tiny pattern of almost green material in there. So those are the chondrules, and that's what gives it its classification. But what's really cool about this particular meteorite is that it's been dated to 7 billion years old. And that's compared to the Earth, which is 4.5 billion years old. And so it's a guess based on theoretical models, but that's what it looks like, that it predates the Earth. But the second thing that's exciting is that the Murchison Meteorite has about 15 different amino acids. So they're the building blocks of life. They're not life itself, they're acids, but in the right forms, they can be a precursor to life. So you imagine a prototypical ocean teeming with chemicals and water, and then you start seeding in these little tiny fragments from the sky, and maybe add a lightning strike or some other event, and maybe that's how you get life. So we've got lots of different other examples. Here's a palisite, which is a stony iron. It's got iron, nickel, and then it's got olivine in it. We've got examples of regmaglyphs, those little thumbprints that you see on the outside of some larger meteorites. We've got examples, we've got information about different meteorites that have been known and what their likely composition is. The moon turned out to be a good place to find meteorites. So there's a lot of different information. You can learn about strewn fields, for example. This is an example. The meteorite fragments were coming in from the bottom of the screen, and what you will find that's interesting is the big ones, the 70-pounder and the 35-pounder, are at the top or far end of the strewn field. So it's not like it was in water and the heavies come out first. The heavies have more momentum and they fly the largest. So that's an example of the Homestead, Iowa. So there's lots to learn, lots to find out. I invite you to come out to the museum once the social distancing restrictions are lifted and get to know the Murchison Meteorite and learn more. Thank you.